So now that we've learned long division, we're gonna do synthetic. No way, just joking. Okay, so let's go through the long division. This is review, and we're going to compare how long division compares to synthetic division. And I know it's going to be hard to take me seriously in this costume, but please try. Okay, so just going through the question that was on your homework quiz, you had 3x cubed minus 7x minus 9 divided by x minus 2. What did we have to remember with that polynomial? We needed a placeholder for the 0x squared. So if you set it up where you had your polynomial, the division bar, and your divisor on the side, you're going to get 1 mark. Okay, so we always place our divisor on the side and our polynomial underneath the division bar. So if you did that, 1 mark. If you forgot that placeholder, no mark. Okay, you need to make sure that you have a placeholder for the x squared. So in the polynomial, you didn't have a 0x squared. You need to put that underneath the bar. You have to.
Why?
Okay, so this is our original polynomial. This is what we're dividing by. We're going to review the steps from last week, how to do long division. Okay, so first, with our divisor on the side, we're going to look at the term as a variable, so x. We have to think to ourselves, x times what will give me the first term in the polynomial, 3x cubed. So we're for sure going to need a 3. And then x times what gives me x cubed? X squared. Then what do I do with this 3x squared? Who remembers? How do I bring it down? I gotta multiply it by both terms in the divisor. So 3x squared times x is 3x cubed. 3x squared times negative 2 is negative 6x squared. So we've divided, we've multiplied. Now what does sister do? Subtracts. 3x cubed minus 3x cubed, subtracts. Okay, cancels out. 0 minus negative 6x squared, we get positive 6x squared. So 0 plus, so negative, negative, so we're subtracting this. Okay, 0 minus a negative 6 is actually like 0 plus 6x squared. We get positive 6x squared. Okay, so dad divides, mom multiplies, sister subtracts. What does brother do? Bring down the next term, negative 7x. And yes, this is like going back to grade 6. I never learned it that way either, but Mr. Panjwani, he brought this. Or introduced it, I guess. Okay, so we had 6x squared, we brought down the negative 7x, and we start all over again. So, x, dad's going to divide, basically 6x squared divided by x. What's 6x squared divided by x? Or x times what gives us 6x squared? 6x. So x times 6x gives me x, or 6x squared. Multiply that through, 6x times x, 6x squared. 6x times negative 2, negative 12x. Okay, we've multiplied now, sister subtracts. So 6x squared minus 6x squared cancels out. Negative 7x minus minus, so negative 7x plus 12x gives me positive 5x. What does brother do? Brings down that negative 9. And we start over again. X multiplied by what will give me 5x? 5. 5 times x, 5x. 5 times negative 2, negative 10. Then we subtract. 5x cancels out. Negative 9 plus 10 is positive 1. So, we should have had a divisor of x minus 2, a quotient, what's on the top here, 3x squared plus 6x plus 5, and our remainders on the bottom. The original polynomial was given. So polynomial equals divisor times quotient plus our remainder. So that's long division. And just to summarize what everything is again, here we had our divisor. Here we had our polynomial. What do we call this on top? What's this? divided the following. The dividend is really what we're calling our polynomial, pretty much. Okay. So now let's compare this long division with a new type of division called synthetic division.
Yes.
And we're lucky the first two examples have been given for us, so we just get to observe the process. That one was out of 3. So you get 1 for the initial setup, 1 for getting the correct quotient, and 1 for getting the correct remainder.
So it's 6 points now?
6 points in all, yeah. And because it's Halloween and I'm generous, I'm only going to look at the first 3 marks anyways. Okay, I'm just going to hand around the homework book box. If you could hand it in, please. Thanks.
Thanks, Brian.
Okay, as the box is coming around, we are going to continue. So, introducing synthetic division. We're going to compare how that relates to long division. And the numbers are exactly the same. It just looks different. So the one thing I like about synthetic division is you're not messing around with variables. It's just numbers. And I like using numbers a lot better than lots of variables. Okay, so a student here shows how she or he did synthetic division. I want you guys, just looking at part A, let's just guess, where do you think that 2 came from? Okay, just a reminder, we are dividing 3x cubed minus 7x minus 9 divided by x minus 2. The 2 on the side, where do you think that came from?
2 on the bottom.
2 on the bottom? That's negative 2. So you are right. Okay, the 2 is coming from the divisor. And basically it's the value of x when you set the divisor equal to 0. So for example, when we had x minus 2, if we set that equal to 0, what does x equal? Positive 2. So d of x just stands for divisor. Okay, so that's where this 2 came from. And if you want, you can label that. That's the divisor. Part 2, the numbers 3, 0, negative 7, negative 9 on the top row, right here. What do you think those represent? This is what we're dividing. The coefficients of the polynomial. Good. And just like in long division, it's important that although we don't have an x squared, we still need a placeholder, which would be the 0. Okay, so the divisor goes on the side. The coefficients of the polynomial go in the top row. Okay, now comparing to what we answered in the first part, doing long division, part 3, why do you think 1 is circled here? Good, so the remainder. Okay, and then part 4, what do you guys think that the numbers 3, 6, and 5 represent? Right here. Compared to the long division up top. Quotient, perfect. Okay, so if we look, that was our polynomial, divisor times quotient plus a remainder. Okay, we have our divisor on the side, our original polynomial, the top digits. The remainder is always the far one on the right, and going from right to left, we have our quotient. So just to tell you what 3, 6, and 5 stand for, we have 5 as our constant, 6x, and 3x squared. As you move to the left, the power on the x variable increases by 1. So we have x to the power of 0, x to the power of 1, x to the power of 2, if I had one more, x to the power of 3, they would just keep going. Okay, so the numbers 3, 6, 5 represent the quotient, or the coefficients on the quotient. Now for part B, it's asking you to identify how the sets of numbers 6, 12, and 10, as well as 3, 6, 5, and 1, how you figure those numbers out. So instead of putting that in words, I'm just going to go through the process first of all, the steps on how we acquire everything. Okay, so first thing is you want to figure out when you set your divisor, x minus 2 equal to 0, what is the value of x equal to? And we figured out it's 2. And you're going to write the coefficients from the polynomial in the top row. We have 3x cubed, 0x squared, negative 7x, minus 9. First step, you bring down that first coefficient, 3. You're going to take that 3 and multiply it by the divisor. Whatever you get, so 3 times 2, you place in the next column on the bottom row. And then you just add. 0 plus 6 is 6. And we start again. 6 times 2, 12. Okay, negative 7 plus 12, positive 5. 5 times 2 is 10. Negative 9 plus 10 is positive 1. Easy as that. So, let's go through an example just to make sure you guys understand the steps. So first thing I'm going to ask, where did they get that 1 on the side? Good. And x minus 1 is called what? Divisor. Good. And what do we call this? Polynomial. Okay, so if I wanted to set this equal to 0, x would equal 1. So that goes on the side. The polynomial is given by 2x cubed, negative 3x squared, negative 8x, positive 15. First step. What do I do with this 2? Bring it down. What do I do with the number on the bottom and the divisor? Multiply. 2 times 1 is 2, so I place it in the next column, bottom shelf. Negative 3 plus 2, negative 1. Negative 1 times 1, negative 1. Add those together. Negative 8 minus 1, negative 9. Negative 9 times 1 is negative 9. 15 minus 9, positive 6. Okay, who knows the remainder? 6. Good. It's always going to be the far right number. And then this is your quotient. We always start with a constant, so we have negative 9 as a constant. We have how many x's? Negative 1 x's. And we have 2x squares. So we have our remainder, our quotient. This came from our divisor. And this came from our polynomial. So now we can put it into this form. Polynomial over divisor equals quotient plus remainder over divisor. So our original polynomial, 2x cubed minus 3x squared minus 8x plus 15 over our divisor, x minus 1, equals our quotient, 2x squared minus x minus 9. Okay, we got that from the bottom three numbers on the left. Plus, what was our remainder? 6, farthest number on the right, divided by our divisor, x minus 1. Alright, next one. Consider the polynomial 5x to the power of 5 minus 6x to the power of 4 plus 3x squared minus 2x plus 1. Lots of numbers there. Which placeholder do we have to remember? Good, 0x cubed. So we're going to set it up. I'm just going to do it on the side here. Okay, based on this divisor, x plus 2, what number will go on the side? Negative 2. Good job. Okay, list off the coefficients. Yep.
6, 0,
Uh-huh.
3, negative 2.
Good. Okay, it's really important to remember the placeholders. And if you guys want, you could write over top. This is the x to the power of 5, 4, 3, 2, 1, 0. Okay, that way you know you have all the spaces. Is this step really necessary though? No. Maybe when you initially start, make sure you have a placeholder for each, but I would recommend that you'd need to do it later on. Okay, so let's run through this. Bring down the 5 and multiply through. 5 times negative 2 is negative 10. Add those together, we get negative 16. Negative 16 times negative 2 is positive 32. 0 plus 32 is 32. 32 times negative 2 is negative 64. 3 plus negative 64 is negative 61. Negative 61 times negative 2, positive 122. Add those together, we get 120. So negative 2 plus 122 is positive 120. 120 times negative 2 is negative 240. 1 plus negative 240 is negative 239. Alright, what's my remainder?
Negative 239.
Negative 239, good. Okay, and based on these digits, let's just state our quotient. Okay, starting with 120, that's my constant. Minus 61x, so you gotta add those together. Okay, plus 32x squared, minus 16x cubed, plus 5x to the power of 4. So you'll notice that if we're dividing a polynomial with degree 5 by a binomial with degree 1, the quotient has now, okay, x to the power of 5 divided by x is x to the power of 4. So we're just 1 degree lower. Now I'm going to show you guys a little trick. If you're ever asked, sorry, did I make a mistake?
Yeah, I think it's just, is it supposed to be 5x? Wait, what happens to that? Because since you divide it, wait, so then what? Oh, that's just the quotient.
You know what, Joe's good question. So when we started the polynomial, I labeled what all the spaces were, right? When we go down to our answer, we've kind of moved over one because this is our remainder, and then this starts again at x0, x1, x2, x3, x4. Okay? So it just gets shift over one.
Okay, thanks.
Okay, so for part B, I'm just going to show you guys a shortcut. If you're ever asked only to find the remainder and you're not concerned about finding the quotient and the remainder, so just the remainder, there's a little trick. So to find the value of the polynomial, when x is replaced by -2, basically it's going to give us our remainder. Where did they get this -2 from? The divisor. So if we go p of -2, we're going to replace that into the original polynomial. So every x is replaced with a -2. We get 5 times -2 to the power of 5 minus 6 times -2 to the power of 4 plus 3 times -2 to the power of 2 minus 2 times -2 plus 1. Whatever we result in there, that will tell us our remainder. So by summing the value of what x equals when the divisor is equal to 0, we get our remainder. Okay, so the value of x when our divisor is equal to 0, subbed into the polynomial, always gives us the remainder. And without cheating and looking at what we just solved for, make sure you actually calculate it out. Do you guys get -239? Brett's verified it. He's concluded, yes. Our remainder is -239. So that's just a shortcut. Any questions so far? Okay, before we do example 3, I actually want to, just based on what we did there, let's go ahead to example 4 and we'll go back to example 3 after. Okay, so the next question says a polynomial where one of the coefficients is a is divided by x plus 2. Okay, and they're telling us that the remainder is 3. Determine the value of a. So what did I just tell you guys about that little rule there? If you sub in the value of x when your divisor is equal to 0, what do you always get? The remainder. Okay, so what is the value of x when the divisor is equal to 0? You heard it, okay? X is equal to -2 when the divisor is equal to 0. So knowing that, if we sub that value, -2, into this polynomial, we can then replace that value with our remainder 3 and solve for a. Okay, so our remainder will equal the polynomial at -2. What was our remainder? What did they tell us? 3. So we're going to replace that with a 3. And p of -2, going back to the functions unit, that's just replacing every x with a -2. So 2 times -2 cubed minus 4 times -2 squared plus a times -2 plus 3. So we're multiplying through a bunch of values, and we have one unknown, an a. So solve for a. I'll just give you a moment to do that. Okay, and if I just look at both sides, these 3's can cancel out. Here I get -32. If I move it to the left-hand side, I get +32. That equals -2a. Divide by -2, and what does a equal? negative 60.
Because like the minus it.
So
3 minus 3 is
the reason why I can just cancel those 3's out is if I wanted to say move this 3 to the other side,
Okay, I got it.
I'd subtract 3, which means I'd also subtract 3 on that side. They would cancel out.
Thank you.
Okay, so just by knowing this rule, that I can sub in the value of the divisor of x when the divisor is equal to 0, by subbing that in and setting it equal to the remainder, I can easily solve for unknowns. And speaking of solving for unknowns, we're going to do a little rewind, go back to example number 3. We're just going to solve it in a little bit of a different way, using synthetic division. The next question we could have also solved using synthetic division, but the way I showed is a lot easier. Okay, so x plus 3 is our divisor, and using synthetic division, given what they've provided us, we have to solve for m and p. Okay, so if our divisor is x plus 3, what are we putting on the side? Negative 3, good. Okay, they've done step 1 for us. They've brought that 2 down. We're going to multiply 2 times negative 3, and we get negative 6. Add those two together, we get negative 4. Next up, negative 4 times negative 3 is positive 12. So now we have the unknown m. Let's just highlight this section here and do a little bit of side work. They're telling us that negative m plus 12 equals 2m. Is it possible to solve for m? Yeah, we just have a little equation. So add m to both sides, and we get 12 equals 3m. Divide by 3, and m equals 4. So now that we know m equals 4, can I sub it back into m and carry on? Okay, so if I sub 4 in for m, I get 2 times 4, which gives me 8. And we can just proceed with our synthetic division. 8 times negative 3 is negative 24. So n equals negative 24. 16 minus 24 gives me negative 8. So m is equal to 4. P is equal to negative 8. Do you guys want to go through example 4 using the same technique as we just did? Or are you good with the remainder theorem? Okay. Okay, so lastly, we're going to learn how to do synthetic division, but this time instead of dividing by, say, x plus 2 or x minus 4 or x minus 3, we now have ax minus b. So there's a coefficient in front of the x, which makes it a little bit different. So for example, we have the polynomial 2x cubed plus x squared plus 5x minus 1 divided by 2x minus 1. And whenever we're dividing by a binomial where we now have a coefficient, it makes our steps just a little bit different. Okay? Very similar though. So first thing you need to do is you're going to look at your divisor, 2x minus 1, and you're going to, so we have 2x minus 1. First you're going to factor the coefficient off of the x. So if we factor out a 2 from the first term, we're left with just x. 2x divided by 2 is just x. Okay, and negative 1 divided by 2 is negative 1/2. So we factored out a 2 from both terms in the binomial. Okay, then what we're going to do is we're just going to divide by x minus 1/2. So if I had to figure out the value of x to set that divisor equal to 0, what would the value of x be? A little louder? 1/2, yeah, positive 1/2. So that's going to go on the side. And now we just start division. Okay, so carry down the 2. Half of 2 is 1. 1 plus 1 is 2. Again, half of 2 is 1. 5 plus 1 is 6. Half of 6 is 3. So we get 3 minus 1 is 2. And we're done. That's our remainder. And this is like our quotient for now, but I'm going to call it our fake quotient because we have to do one more thing with it. Okay, so from what we get in synthetic division, you would write it out in the form polynomial is equal to your divisor times your quotient plus your remainder. So based on what we have from our synthetic division, we have 2x squared plus 2x plus 6 and our remainder 2. Okay, this is like our fake quotient for now. Okay, so writing it in this form, based on what we have, we first divided by x minus 1/2. That's why we had positive 1/2 there. We ended up with this quotient and our remainder positive 2. What we have to do is look at the quotient we found, and we are going to factor out a common factor. And surprise, surprise, it's the 2 that we factored out originally. So factor it out here.
Junior class change.
Factor out the 2. And that leaves this quotient looking like x squared plus x plus 3. We divided each term by 2. Okay, then what we're going to do from this step to this step is we're going to multiply that 2 back into the divisor. And when we do that, we get 2x, and half times 2 is just 1. So we have 2x minus 1. That's our original divisor. Okay, the quotient that is legit is the x squared plus x plus 3 plus the remainder 2. So you're only factoring the 2 out of the quotient. So our quotient is x squared plus x plus 3, and our remainder is 2. So I think that's that one needs a little more practice. So let's do one more together. Did you have a question?
No.
No? Alright, so we're dividing 6x cubed minus 8x squared minus 5x plus 5 divided by 3x plus 2. So let's set up our division. And I'm just going to put in the polynomial coefficients to start. So I have 6x cubed, negative 8x squared, negative 5x, positive 5 as my constant. From the divisor, if I factor out a 3, I'm left with x plus 2/3. So factor a 3 out of both terms. And maybe I'll draw an arrow on the side so it looks a little more connected. Okay, so we factored this out. Now this divisor is where we're going to get our x value that we put on the side. Okay, so it will be negative 2/3. And then we just start dividing. So carry down the 6, and I'll just walk you through how I'm doing it in my head. Some of you might instantly go to your calculator, but you don't need it. 6 times negative 2, negative 12. Negative 12 divided by 3, negative 4. Okay, add these together, we get negative 12. Negative 12 times negative 2, positive 24. 24 divided by 3, positive 8. Negative 5 plus 8 is positive 3. 3 times negative 2. Negative 6 divided by 3 is negative 2. And lastly, just add together 5 minus 2, we get positive 3. So the 3 is our remainder. And this is our quotient. But remember, our fake quotient. So we have our polynomial is equal to, right now our divisor is just x plus 2/3. The quotient that we found from the bottom is 6x squared minus 12x plus 3. And our remainder was 3. What do I have to remember to do with this quotient? Good, factor out of 3. So when you get really good, you won't have to do these 2 steps to do it, but I'm just going to show you that I'm factoring the 3 out of that. So 6 divided by 3 is 2x squared. Negative 12 divided by 3 is negative 4x. 3 divided by 3 is 1.